In this lesson, we will investigate polar graphs. We're going to have lots of little formulas for different graphs. You won't have to memorize them all, but you should be familiar with some of their characteristics. So the first thing we're going to look at lines. Now, since polar graphs, usually you use polar stuff for rounded things, circular, oval. Lines, not so much. But here are what the graphs of lines look like. So the easiest one, and probably the one that is most useful, is if theta is just equal to an angle. So we have an example of theta equals pi over 3, or if this helps you, you might want to think about 60 degrees. So you have a polar graph. Remember, that's 0, and all of these were every 15. So here is 60 degrees, or pi over 3. Well, in order to graph a line, you're saying all the points that go along that line or that angle. Well, so these would be all the positive r's, and as we talked about in the last lesson, you can have negative r's as well. So that would be the line theta equals pi over 3. Now here we have another line. In the last lesson, when we learned to convert from polar to rectangular, we learned that the relationship that r cosine theta is the same as x. Well, hopefully you remember from college algebra, if you have x is equal to a number, that is always a vertical line. Right, so here we have r cosine theta equals to 4, or we can think about x is equal to 4. So if you want to think about this being your x-axis and this being your y-axis and kind of really throwing out the idea of polar, you go out 1, 2, 3, 4, and you'd have a vertical line. When you graph that on a graphing calculator, it's going to plot the points very strangely, but eventually you would end up with a vertical line. So here we have r sine theta equals a, and again that relationship is y. And you should remember that this is always a horizontal line. So here we have y equals to negative 3, and again if you want to think about that as x and y, we would come down here on the y-axis 1 to negative 3, and you would have your horizontal line. Before we go further, I want you to look at this and this. This equation has cosine. How is that vertical line symmetric? Well, it's symmetric with respect to the x-axis, meaning the x-axis acts as a mirror. So it's symmetric with respect to the x-axis. Now, if we look at this line, and we have r sine theta, and now we have a horizontal line, what kind of symmetry does that graph have? Well, it's symmetrical with respect to the y-axis. You're going to see that as a pattern. Remember, sine kind of goes with y, usually going to be symmetrical with respect to the y-axis. Same thing for cosine, goes with x, symmetrical with respect to the x-axis. So what's the next type of graphs we're going to look at? Circles. Now that actually makes sense for polar graphs. So if we have r is equal to a, which is the easiest type, let's go ahead and graph that. R is equal to 3. Well, on your polar graph, each circle is one unit on here, so 1, 2, 3. Here, along this circle, the radius is always 3. So you can see that's a nice, easy circle. The center is at the origin. Okay. Well, let's look at this. Well, we know the radius is 3. So what would be the diameter? Of course, it would be 6. Well, let's look at this one. We have r equals plus or minus 2a cosine theta. Well, we know cosine theta has some relationship with x, but what does this graph look like? Well, we could plot some points, but it's not going to help us too much. Okay, so let's say if I let theta be 0 degrees. What's the cosine of 0? It's 1 times negative 2. This is a good opportunity to remember how to plot points. So at 0 degrees, instead of going towards 0, we would go back. So that's 0, negative 2. Well, what if I let theta be 90 degrees? Well, the cosine of 90 is 0. So at 90 degrees, we're at the pole. Remember, we call the origin the pole. So 180 degrees. Well, the cosine of 180 is -1 times -2, +2. Now where's that point? Well, here's 180 degrees, and if I go toward that, that's that same point. So in order to get some more points, I would have to crank out a calculator. But I'm just going to tell you this is what, and this isn't going to be great, this is kind of what this circle looks like. Right? The center is going to be right there, and the radius is going to equal to 1, so that means the diameter is 2. Also, it is symmetric with respect to the x-axis, and that corresponds to what we were talking about earlier. Cosine goes with x. So what about this one? R equals 6 sine theta. Well, we can kind of go through the same thing. If we let theta be 0 degrees, but the sine of 0 is 0. So we would start out at the pole. Then at 90 degrees, the sine of 90 is 1 times 6. So up here, 1, 2, 3, 4, 5, 6. At 180, we get back to 0. We're back down to here. And 270 degrees is -1 times 6 is -6. So even though this is 270, instead of going toward it, we'd go back and we'd end up with that same dot. So again, 2 dots isn't much. We'd have to plot a bunch more points. But if you did, and again, I'm going to try to be as circular as possible, you would get, we're going to pretend that that's a circle where the radius is 3 and the diameter is 6, and it's symmetric with respect to the y-axis. Alright, so that sine theta goes with y, and that's symmetry involved. So if we're going to come back up here and answer that question, the blank of the circle is 2a. So looking at these formulas, 2a corresponded with 2, 2a corresponded with 6. So what did that number equal to, the radius or the diameter? It's the diameter. So the diameter of the circle is that coefficient of sine or cosine. Now we are going to get out our calculator and just do some investigating. So you want to make sure that when you go to your mode, that's in degree mode, and then polar mode, right there, P-O-L. And since we're in degree mode, our window, let's go to window, the min and max need to be from at least 0 to 360, because again we're in degrees. This is just the default on the calculator. They go every 7.5, means it's going to plot a point every 7.5 degrees. And you can always go to just zoom option 6 and you would get that correct window. Now let's go to y equals, and I'm going to clear what I have. So I just want to graph 3 plus 3 cosine theta. So if I do to zoom 6, which is the standard viewing window, let's see what I get. Okay, so I'm just going to kind of sketch that on my paper. So this one looked something like that. That's kind of funny that mine looks like that, but it is symmetric with respect to the x-axis. Now let's go to zoom and come down here, zoom 0. That's zoom fit. It's going to fit that graph to the viewing rectangle. Maybe you can see it a little bit clearer. So count, how far is it between here and here? 1, 2, 3, 4, 5, 6. So this is 6 wide. And then on the y-axis, count 1, 2, 3, 1, 2, 3. So up here is 3, down here is 3. And don't you think it kind of looks like a heart? Some people say like a bean, maybe a sideways apple. But let's see. Those are 3's, and if you add them, you get 6. And it's cosine. It's a plus sign. It's symmetric with respect to the x-axis. Now let's look at this one. So the only thing we need to change is the minus sign. Let's go back to R. So you can type it in, you could clear it, or you could just get on top of the plus sign and put a minus. And I'm going to go to zoom option 0 again, zoom fit, and see what happens. It looks just like the other one, except turned sideways, kind of on the negative part. But if you count again, this is 3, and that total is 6. Well, now let's throw in some signs. Let's look at that one. Alright, so I'm just going to clear what I have. 3 plus 4 sine theta. And again, I'm going to go to zoom option 0. Ha! This time we didn't quite get a heart-shaped figure. Kind of did, but it had this little loop inside. But again, let's count along the x-axis and see what we have. We have 1, 2, 3 maybe, and 1, 2, 3. Okay, so let's write that down. So from here to here it looks like 3 and 3. Okay, that loop is one big, 1, 2, 3, 4, 5, 6, 7. So that whole thing is 7, but the loop is 1. Well, let's see, 3 plus 4 is 7. You might need to think about where those 3's, but it's sine, and it is symmetric with respect to the y-axis. It's on the positive part, maybe because of that plus. Let's do this last one. So we have y equals, I'm going to clear that, 5 minus 3 sine theta. Make a prediction before you hit graph. And if you just hit graph, you might not see it, especially if you've done zoom 0. So I'm going to do zoom 0. No loop. It's kind of really flat and then kind of rounded like that. And let's see if I count 1, 2, 3, 4, 5. So out here is 5, out here is 5, and if I count in the y direction, 2 up, 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 down here, 2 here. 5 minus 3 is 2, 5 plus 3 is 8, and that leading number is 5. There's a minus, and most of it is on the lower x-axis, or the negative part. I'm sorry, the y-axis, and it is symmetric with respect to the y-axis. So first of all, this exercise is to show you how you can use your TI-83 to help you graph polar mode, but your mode, if that's in degree, your window needs to be like 0 to 360. And if you want to make sure it is, you can always do to zoom 6, which is your standard viewing window. Alright, so degree, polar mode, check that window, and you can always change it with your zoom 6 button. And so you can see that's my last thing, and you can see how it looks a little bit different. So what I wanted you to get from this is the symmetry, the pluses, the minus, and some of the relationships with those numbers.